All right, ladies and gentlemen, let's now continue with our session post-lunch. I request everybody to kindly please settle down. So, my dear friends, digital twinning. Yes, live digital twinning is what we are proceeding towards. Hexagon is a global leader in digital reality solutions combining sensor, software, and autonomous technologies. Hexagon is putting data to work to boost efficiency, productivity, quality, and safety across industrial, manufacturing, infrastructure, public sector, and mobility applications. Their technologies are shaping the production and people-related ecosystems to become increasingly connected, yes, and autonomous, ensuring a scalable and sustainable future. So today we have with us Mr. Navaneet and Mr. Milind, and I request them to kindly please come onto the stage because they'll be talking about laser scanning and how it is used to solve real-world problems quickly and accurately. So we would definitely want to know that. I request, yes, Mr. Navaneet and Mr. Milind to please step forward.
Can you hear me? So warm welcome to you all. There is a timer here which I was not aware. So first, I mean, you are seeing a large scanner on your left, on my left, and you are seeing a city with the dots, with triangulations, etc. So essentially, what you will be seeing in next minutes is how if you take something as high-end, LiDAR scanning, SLAM technologies, and apply basic geometry to it, how you can merge these two worlds together, the real and the digital. So before I go into the details of it, a brief introduction about Hexagon. So Hexagon, we believe that we have core capabilities of sensing things. And sensor could be tactile, touching, or laser, very clearly. And at the same time, finding the position. We have the possibility of finding position accurately up to 1 centimeter anywhere on the Earth, because some of the missiles, the flight plans, they all use those sensors to find out where we are accurately. We have, in many states, already installed in India and obviously across the globe, about the position correctness, the RTK services to find out what exactly your position is. That is one part of it. The other part is scanning using laser or any other method, finding out data, and then applying it in the real world. The story, what we are trying to say is, yes, you can have a lot of software, but your cycle of completion will only happen when digital and real world comes together. So when we put this together, what happens is you capture data in the most advanced manner, and your advanced has to be quick as well. Because if it is taking a lot of time, you are not able to actually help someone. We will see how these scenarios are helping these days people for the most complex problems. Then you obviously take it to the software world where you apply all your logic, try to find a solution, and in the best case scenario, let the machine decide. Because if machine is deciding, then there are mistakes, chances of mistakes being happen is less and less. So that is the feedback loop which comes back from the software back to the real world where you do this. So essentially, this is what digital reality should be. You take real world, scan the data, send it to the software, get the results and actions what needs to be done, implement it back in the real world. So this is how the loop gets completed. This is what the digital reality is. So I will move forward from here, and we'll say that sorry, there are other basic technologies not at work. I'm trying to click the forward button, but yeah. Yeah, I know that. I was pressing the screen. Okay, so let's look at this engineering or R&D marvel that has been created some time back. What does it say? It says that, the laser scanner, the LiDAR scanner, as you see on the top, that can capture more than 400,000 points per second. What it says is that we have the possibility of high-resolution camera to get the exact details in line with, along with capture data by laser. Why do we do this? We'll come back in a minute. And then panoramic vision. Why do you need panorama? Because earlier, when you used to scan things, you were static. Your measurement tools were static, and now it is not. So now what is happening is your tools are actually moving, and that means you need to stitch things together as you move along, because that is what will give you speed. That is what will give you the faster solution. And then the field of view, 360-degree and 270-degree in the vertical, because as you can see at the top, there is a dome-like thing. That means this is how it can scan. And finally, its range is from your nearest wall or the things that you want to scan. You can be as far as 25 meters, that is more than almost at like the width of the hall, or as close as half a meter. Other details as to how it communicates, that is mostly understandable. But now coming to, what are the technology used? So just, again, I will not spend time here, but it is called SLAM, where you are trying to simultaneously localize things as well as map things. Sounds very unintuitive, because either you know your location or you know where the wall is. How you can find out both, but that is a computational problem, gets solved when you start putting probabilistic theories and find out a solution, and then you find, and that's why when it is simultaneously both localization and mapping, we start calling it SLAM. What you do is you do it with a laser. You also do it with visual SLAM, because normally we are visual people. If we just show you a point cloud without any color, without any sense of place, you will not be able to say what is wall and what is chair, or probably what color it is. So the moment we start merging that, putting that together along with these visual pictures, and why panorama? Because you start stitching it together. As of now, this hall is very, very simple. It is on one floor. Just imagine if we had to do the whole HICC, and you wanted the whole HICC scanned, a digital map of this being available in next 20 minutes. Nothing as of now can help you barring this kind of tools, which lets you scan things along with laser and picture while you are walking. The moment you put something static, it's going to take a lot of time. And that is what we are solving by putting visual SLAM. The third piece, again, science and engineering, is what we used to earlier when we were in 12th reading engineering, that we found out that about if you know the acceleration and if you know the rotation, you know exactly how much you have moved. This is very, very important technology. What happens to your GPS when you are inside a tunnel? You still know where you are, because when you last left the satellite signal, and now when you're moving, if you know exactly which direction you are moving, at what speed you are moving, what are the turns that you have taken, you know exactly where you would be. So that is the IMU. You put this all together, and this in terminology is called Grand Slam. So this Grand Slam is where all this data gets stitched together, and you are able to find an exact replica of the real world into the digital setup. So now what I will do is, this is theory, yeah? And now you should believe it. The idea is I will invite my friend Milind now. He will start scanning actually this hall along with you. He will then come back on the stage after scanning, probably take a couple of minutes for him. And then he starts showing you how he processes this data, what kind of results he's able to get from it. And again, you will be able to see what is a real world. This room eventually gets mapped to a digital world. There he does some operations that is needed, that is real world operations, and digital world operations, and bring it back to real world to do the next steps. So that is what we are going to see. Again, we have tried to keep this a very simple model so that you are able to understand that this is not the technology of future, this is what is happening now. After he has shown it to you, I will come back on the stage and will tell you what problems we are already solving with this. Milind, yours.
Yeah. Thank you, Navaneet. So what you are seeing on the screen right now is the iPhone screen, which I am holding in my hand. And this is the BLK2Go device, which is the scanner. I just initialized it. I'm just going to walk around. I hope the screen is live. It's not so live. Just give me a moment.
So now what you're seeing essentially is which path he's taking inside the hall, and what data is able to captured by the BLK to go device, which is being replicated in his mobile, and that mobile replication is happening here.
Yeah.
You can start with the workflow then, Milind.
Yeah. Sorry, the mirroring is not working for me as expected.
Milind, I think we can go to the screen again.
Yeah. Yeah, so what I really wanted to show you was the scanning live. I'll maybe try it again later, but let me first cover the other aspects of the workflow. So, yeah. So yeah, so using the BLK to go, you can definitely scan the device, and once you have scanned the data, then you can basically put it to use. So I'm going to show you a brief workflow of how this works. First, we scan the data using BLK to go. Then basically we import it into a laptop or a desktop. Based on that, we have a software suite called Cyclone, under which there is a Register 360 utility, Register 360 product, which basically connects to the BLK to go, pulls down all the data, helps clean it and process it. Once the data has been cleaned up, we export it from a custom format which is inside the device to a well-known format like E57. Then once we have the data, then we basically use it for doing a processing. For example, if you want to build some kind of a structure or modify a structure in an existing environment like this, so how to do it? So these products like Icon Office, they basically help you in defining those geometries and then doing the required calculations on top of them. So I'm going to take you through a very small workflow here to show you exactly. So we did a scan of this particular hall earlier in the morning before the event started, and then based on that, we built a small workflow. So I'll just take you through that quickly. So the first step is to download the data from the device. So basically the device exposes a Wi-Fi hotspot, and it has a HTTP server on it, using which we can access the various data sets which are available on the device. So you can see a list of devices. You can just download it on your desktop from a browser. And once you have the data, then basically you can start the Cyclone Register 360, and then basically import the data which you have downloaded on your desktop into the product. And this is basically, once it is imported, so it's raw data still. It is not yet registered, not oriented properly. Coordinate system is what the device has seen, not something that which we have defined. So the next step is to basically go ahead and set coordinate system and the orientation of the data. So what I'm going to do here is basically select one corner of the data set and define it as my origin. And then once that has been done, I also want to make sure that the data is aligned properly, oriented properly. So I'm just going to use the Register 360 product to basically orient the data that we have captured. Once the data has been oriented, then so I captured much more than what I really wanted. For my workflow, I just want to make a ramp, from here in the stage to the floor, maybe somewhere near that first row of the table. So I don't need the whole data, so I'm just going to filter out what I don't need. So that's why I have defined the limit boxes here, and remove whatever I don't need and making the data compact. Once we have defined the limit boxes, then we can basically export. We are ready to export this data now and save it to some kind of a well-known format. So that's about it. We accept whatever changes we have done to the data, and finally just publish the report. So it basically saves the registration of the data, how we had changed things, and also exporting it to the E57 format, which is the well-known point cloud format, basically. And yes, when we are exporting, we are basically selecting the limit box that we defined, because if you don't select it, it will again export the whole big data set out. So once you have the data now ready, it's time to basically take it into the Leica Icon Office software. So here I'm just taking, because I want to define the ramp from stage to the floor, I don't really need the roof and stuff. So I'm just going to cut out the data using some filters and just use the floor data, or the data only till few meters from the floor. You see that there is quite a bit of noise in front of the stage. There were some people moving around, and some noise came in while I was doing the scan. So what I can do is I can go ahead and filter out the data and noise. So I'm just going to define some 3D filters here, and it's going to just make sure that I'm only looking at the floor data to define my geometries, and basically cut out all the noise from it. So I'm just choosing the area which I'm interested in, extruding my filters, and then applying it. So when I defined it, basically the base was pretty low, so my actual floor data also got lost. So I'm just adjusting my floor a little bit so that I don't lose the floor data, but remove all the noise on top of it. So once the data is clean, now I am ready to define the ramp. So I am actually trying to define a ramp in this area between these two speaker boxes here. So what I'm going to do is I'm going to pick a couple of points from the stage here that you can see, and then pick a couple of points on the floor. So basically I'm defining two line segments, one on the stage and one on the floor. And using these two line segments, I'm going to create a surface. So the Icon Office software, it has many such useful tools. You just give it a little bit of information using the point cloud and the geometries. It can basically go ahead and create the ramp surface. Once I have the ramp surface, but I need something which is the base of this ramp to do my actual calculations that I want to do. So for that, I'm going to extract the ground surface. Again, the software is providing these useful tools to basically, when I give it a fence and draw this fence, basically it is able to detect the point cloud data beneath it and able to sort of, create a base, like what is the floor here? It is sort of understand that. And once it has detected that base, then the floor surface has been created. And now what you can see is both the floor as well as a ramp on top of it. Yeah. And once we have this, now we have the two surfaces, and now we can go ahead and basically do the calculations that we on top of this. So what I am trying to do here is just basically calculate some area and volume. So what you will see on the right-hand side panel, if you pay attention towards the bottom of the screen. So I'm first selecting the existing surface, which is the ground surface, and the other surface on top of it, and that basically gives me the volume. So that's briefly about the workflow. how we use the point cloud data, existing data, to extract information and then create geometries from it and do manipulation on top of it. One other interesting thing which I really want to share with you is our platform, the Hexagon's digital reality platform called the HXDR. This is a platform where you can upload your point cloud data sets, upload your geospatial data sets, imagery, and then basically fuse all of this information to collaborate with and create projects basically. So this is how it looks when you log into the HXDR. You see assets on the right bottom and some sample data sets, etc. So what I'm trying to do here is upload the data which I had captured here into the HXDR platform. And when we upload this data, basically the HXDR has many processing engines. So it basically processes the data which has been provided and then makes it ready for usage. I could directly upload the data from the device itself to the HXDR, or I could take it to the desktop, process it, and then upload it. Either of the workflows I can do. So it gives me a view where I can see all my assets, and I can just sort them, and I can also organize them in different projects. So the data set that you see on the top left corner, that is the one which I just uploaded, and HXDR has just started processing it. Once this is ready, then I can visualize it on the HXDR platform, and I can also then do some things like measuring things live on the HXDR platform. So now the data has been processed. On the top left, you can see that, and it is ready for usage. So I'm going to go ahead and use this data to take some simple measurements. So it just shows a simple example of measuring the width of the stage. So I mean, this just shows the power that if you have this kind of data available, so you don't really physically need to go and measure things. Just with the click of buttons, you can basically capture the measurements, save the measurements, share them with people, or do your planning online. So I just did a length measurement. I'm also showing a quick area measurement. And so apart from doing the length and area, we could also basically go and, for example, if you are some kind of a real estate agent, you could put your assets online, and you can create a nice fly-through on top of them. And those kind of things also you can do on this platform. And you can see this, Navaneet will be talking about it again in a moment. You can see this data in some context, which is very interesting.
Thank you, Milind, for this. So guys, what you saw is, we really took this place, did a scan of it, found the things which could be reused in the real world. So you saw the circle happening from real to digital, doing the calculation and using it in the real world. Yeah, this was a very basic scenario which could be done in a room like this. But if we are meeting together, it makes sense that we also discover what already the solutions are happening the moment you start not only with sensors, but start putting AI as well inside there. Yeah? And as this famous quote that I'm trying to quote is that great technology is indistinguishable from really magic. So what you see here on the screen is not a scanner of inside the room or something, but something which is fitted below the bottom of the planes, and if there is a flight plan created, and cities after cities or the whole country sometimes get mapped using this. And use that map, use the other things, and put this together. So let's see what kind of things are possible once you do this. Sometimes when you do scan, if the properly it is not done, or there are noise, there could be confusion like this. And I will just show you in a minute, if you start applying AI on this, how these nuanced things can be fixed, how the people are understood as people and are removed, and how the windows which are crooked starts getting cleaned and become proper windows. So imagine of this how the movies of today's are getting made and how you imagine the scenario. You're able to understand what is a vehicle, get rid of them. So you know exactly if it was not parking space available, how this thing will look like. And now what you're seeing is super mesh. What is super mesh? You try to capture it from the top. You capture the city. You also capture the street, and you are able to seamlessly grow from the overall city to the same street. And this lets you do the large, complex city plannings really, really easy. As we all know that urban population is the most growing numbers in the whole world, not only in India, but everywhere in the world. And if we have to solve those problems, you need this level of details. And if you see something, a platform like HXDR, just imagine the kind of problem that they're solving. I'm sure before the stage was made, people came here, did the measurement, and took something like this. Imagine this is scanned and available for anyone who wants to host an event. Nobody needs to come here. All the calculations, everything that you want is available at an instant and much more accurately. So this is the power of scanning this data using laser, and when you slam, LiDAR slam along with the visual one and try to put it all together. And then imagine that if it was possible to do it for the whole city, that you could go through any building, any area, and find out, okay, how many people can be accommodated in a place. All those calculations is possible. And indeed, when you have this all digitally available, as you can see here, that you not only can remove something which was digitally captured, but you can put something in between the city which is digitally created. So in this, what you're seeing on my screen is that there is a real city, and somebody has designed a future building and is able to put that building in the middle of the city. So with that, it comes to an end. I would like to say that there are immense possibilities, and Hexagon has tried to simplify that from capturing to, initially, what Milind did, he took you through the desktop solution, but later if you see in HXDR, you just upload it. Nobody need to touch it. All the tools are readily available, and you can do a lot of stuff. For example, if you had a building, and somebody is constructing it as you have given him a design, and you, as of now, want to know whether they are deviating from design or not, a typical architect is taking around a week's time or 2 weeks' time to give you the data. With this kind of scanning, it is live. You just walk through, you find out what the digital is, you superimpose with the CAD drawing, and you know the differences immediately and get to know that what they have not done as they should have done it and find the fixes immediately. So with that, it comes to an end. Thank you for your time.